El Niño and La Niña are two powerful phenomena that shape the weather and climate across the globe, with effects that reach far beyond the Pacific Ocean where they originate. Together, they represent opposite phases of a larger climate pattern known as the El Niño Southern Oscillation, or ENSO. By understanding these natural climate events, we gain insights into the forces that drive weather patterns, ocean temperatures, and rainfall, and we see how the entire system of Earth's atmosphere and oceans is interconnected in remarkable ways. El Niño, meaning the little boy in Spanish, got its name from Peruvian fishermen in the 1600s. They noticed a strange warming of the waters along the western coast of South America that seemed to occur around Christmas. When El Niño would arrive, fish populations would decline, and unusual weather would sweep through the region. Little did they know, this warm current wasn't limited to Peru. It was part of a massive change in oceanic and atmospheric conditions that could influence climate on a global scale. This warming event disrupts normal weather patterns, leading to warmer and wetter conditions in some places while bringing drought and dry spells to others. The counterpart to El Niño is La Niña, or the little girl, which represents a cooling phase in the same part of the Pacific Ocean. La Niña events bring different shifts in weather, often leading to cooler, drier conditions in places that would otherwise be warm and wet. Together, El Niño and La Niña create a seesaw effect with warm and cool phases that usually last several months to a few years. This balance of heating and cooling helps regulate global weather, making these events crucial to understanding our planet's climate system. El Niño begins with a disruption in the typical trade winds that blow from east to west along the equator. These winds usually push warm surface water from South America toward Asia, which allows cooler water from the ocean's depths to rise along the South American coast. This process, known as upwelling, brings nutrient-rich water to the surface, supporting vibrant marine life. But during an El Niño event, these trade winds weaken or even reverse, causing warm water to pool in the central and eastern Pacific. Without the usual upwelling, ocean temperatures in these areas rise, disrupting marine ecosystems and affecting the global weather. This warmer than usual ocean surface heats the air above it, setting off a chain reaction that can alter atmospheric circulation patterns around the world. In parts of South America, for example, heavy rains and flooding often accompany El Niño, while drought conditions may hit Australia, Indonesia, and other areas along the western Pacific. The unusual warming of the Pacific Ocean also influences tropical storms and hurricanes. During El Niño years, the warmer waters can reduce the number of Atlantic hurricanes while potentially increasing storm activity in the eastern Pacific. El Niño has a far-reaching impact on ecosystems, agriculture, and economies. For example, countries reliant on fishing, like Peru, experience declines in fish populations due to the lack of nutrient-rich cold water. In agriculture, crops that depend on regular rainfall patterns may suffer, leading to reduced harvests or even food shortages in extreme cases. Flooding caused by El Niño can damage infrastructure, displace communities, and lead to outbreaks of diseases like malaria and cholera in areas with poor sanitation. The global nature of trade means that economic effects from El Niño can ripple across the world, affecting everything from food prices to energy supplies. On the other side of the ENSO cycle, La Niña brings different climate effects. During La Niña events, the trade winds strengthen, pushing warm surface water even farther west than usual. This intensifies the upwelling process, bringing colder, nutrient-rich water to the surface near South America. As a result, ocean temperatures in the eastern Pacific become cooler, which creates different weather patterns compared to El Niño. La Niña tends to bring wetter than average conditions to places like Southeast Asia and Australia, increasing the likelihood of flooding. In contrast, regions like the southwestern United States and parts of South America may experience drier and warmer weather. La Niña also affects hurricane activity, but in the opposite way to El Niño. The cooler waters in the Pacific reduce the vertical wind shear in the Atlantic, which is a factor that can suppress hurricane formation. As a result, La Niña years often see more hurricanes in the Atlantic, with storms that may be more intense. This variation between El Niño and La Niña has a significant impact on disaster preparedness. As communities and countries plan for different kinds of weather-related risks based on these phases, the exact causes of the El Niño Southern Oscillation remain complex, and scientists are still working to fully understand why it occurs and how it can be predicted more accurately. What is known is that ENSO is a natural cycle influenced by the interactions between the ocean and the atmosphere. While El Niño and La Niña events have been documented for centuries, it wasn't until the 20th century that researchers began to realize their global importance. Advances in satellite technology, ocean buoys, and computer models now allow scientists to monitor ocean temperatures, wind patterns, and other factors that contribute to the development of these events. Predicting the onset of El Niño and La Niña is crucial for preparing for their impacts. By monitoring changes in ocean temperatures, trade winds, and atmospheric pressure patterns, scientists can issue forecasts months in advance, giving people time to prepare for possible weather extremes. These predictions are essential for agriculture, water management, disaster planning, and even the stock markets, as investors keep an eye on industries like agriculture, insurance, and energy, which can be affected by the changing weather conditions. Climate change may also play a role in altering the behavior of El Niño and La Niña. Some studies suggest that as global temperatures rise, El Niño events may become more frequent or more intense, leading to more extreme weather impacts. Others theorize that the strength and frequency of La Niña events could also change. Understanding how climate change affects ENSO is an area of ongoing research, as scientists seek to understand whether global warming could lead to an imbalance in this natural climate pattern. In summary, El Niño and La Niña are powerful climate phenomena that affect weather patterns, ecosystems, and economies around the world. They are natural occurrences, part of the larger cycle known as the El Niño Southern Oscillation. These events remind us of the interconnectedness of Earth's climate system, where changes in one part of the world can have ripple effects across the globe. As our understanding of these phenomena continues to grow, we are better equipped to anticipate their impacts and adapt to the challenges they bring.